Hey guys, before we get started with our actual notes today, make sure that you've got your notebook and something to write with. We are doing 2-column notes this time, so in case you've forgotten, look at the screen. This is the setup that we'll be using. Put your questions and vocab on the left. You will have both questions and vocab in this video, and then you're going to provide your answers on the right. I will be grading your summary as well as your notes when I get back, so make sure that you do your summary as well. Your essential question for today is, how do changes in temperature, pressure, and volume affect gases? Good morning, guys. Today we're going to be talking about gas laws, and there is quite a bit of vocabulary that goes with this. So for each page, I want you to write down what's on that page. You may have to pause, and then we're going to go through each of the definitions. So the vocab that I want you to know is temperature, pressure, volume, density, which we've already talked about, and then gas, liquid, and solid, which are words that you should be familiar with, but that I want you to understand in a little bit different way than you might have talked about them before. So we're going to start by talking about temperature. Temperature is a measure of how much heat energy is in your system. Heat is a form of energy, and as you add more energy to your system, your temperature is going to go up, and the particles in your system, the atoms in your system, and the molecules are going to move faster. So when you have more heat, then you have faster moving particles. The unit that we use to measure temperature in the metric system is degrees Celsius. Pressure is the next thing that we're going to talk about. So when we talk about pressure in terms of gases, we're talking about the force of that gas pushing against the walls of its container. So you can think about the air inside of a balloon pushing against the rubber of the balloon, forcing it out. The faster that gas is moving, the more it's going to bounce off the walls of that container, and the higher the pressure is going to be. The unit that we use to measure pressure is called atmospheres, and the abbreviation for that is ATM. Volume is the next vocab word that we're going to talk about, and it's something we've talked about already. Volume is the amount of space that something is taking up. So gases don't have a defined volume. They will fill whatever container they're in. So if they're in a small container, they have a small volume. If they're in a large container, like a room, they have a large volume. Volume has a couple of different units that it's measured in. You can measure in liters or milliliters. If you're measuring something solid, we'll more often use centimeters cubed. Density is another vocab word that we've talked about before. Density is how tightly packed in particles, like atoms or molecules, how tightly packed in they're with each other. So basically, how many atoms or molecules or particles I can fit in one space. So how much mass or matter I have in a given space. So density is found by taking mass divided by volume, or D equals M divided by V. So if I change the volume or I change the mass of a gas, because we're talking about gases specifically, then I'm going to change its density. So if I add more mass, so I'm adding more particles of that gas into the same amount of space, I'm changing the density. If I change the volume of that gas by changing the container that it's in, I'm also changing the density. States of matter are the next thing that we're going to talk about. So you all know solids, liquids, and gases. You know that solids are hard, liquids fill their container, gases are free moving. But when we're talking about particles and the particles that make up those states of matter, we can talk about them in terms of their density, when we can also talk about them in terms of their volume and shape. So solids have tightly packed particles. Those particles can't move around very much. They do vibrate a little bit, but they're not able to leave the area that they're in. They have a definite shape, and they have a definite volume, and they are the most dense of our 3 states of matter. Liquids, the particles that are found in liquids are a little bit looser. Their bonds are a little bit weaker, and they allow for a little bit of movement. They're generally not going to completely leave the area that they're in, but it allows them to slide past each other. Liquids do have a definite volume, so I can measure the volume of a liquid, but they don't have a definite shape. So they take the shape of any container that they're in. So if I put it in a tall, narrow container, it has a tall, narrow shape. If I put it in a short container, it has a shorter shape. I can change the shape of a liquid with the container. And then finally, gases are the least dense state of matter that we've talked about. They're free-moving particles, lots and lots of movement. They can move very fast. They don't have a definite shape or a definite volume. They take the shape and the volume of the container that they're in. And that could be something like a jar or a balloon or a room. A container doesn't just have to be a box. So for this next section, I want you to write down these 4 questions, and then I'm going to show you a video simulation of changing the pressure, the temperature, and the volume of a gas and seeing how those affect each other. So our first question is, how does increasing the amount of particles in a closed space affect the volume and the pressure of that gas? Our second question is, how does decreasing the temperature of the gas affect the pressure? Question number 3, how does increasing the temperature of the gas affect the pressure? So it's the opposite of question 2. And then last question I want you to answer is, how does decreasing the volume of the gas affect the pressure of that gas? So we're going to take a look at our video simulation. You can pause this if you still need to write down these questions, and then we're going to move on. So this is our simulation we're going to use. It's the same as your virtual lab. Over here on the left, I have this pump that looks like a bicycle pump. That allows me to add more particles into my container. I've got a pressure gauge up at the top that shows me my pressure. I've got a thermometer that I can switch into degrees Celsius that shows me my temperature. And then last thing I can do, we'll put these away because you don't need to see that yet. Last thing I can do is I can bring the lid of my container down to change the volume, so decrease or increase that volume. So the first question we want to answer is, what happens when I add more particles? So we're going to take a look at that pressure gauge up at the top and see what happens. So you can see as I'm adding more particles into that container, my pressure starts to creep up, and it'll start going up here much faster in a second as those particles get moving. And you can't see it in this simulation, but if we had volume as well, if we could change the volume of this container, the volume would be increasing as well. Next question I want to answer is, what happens when I change the temperature? So if I bring the temperature down, you can watch at the top with our thermometer what's happening, and then look at our pressure gauge. When I brought that temperature down, the pressure decreased as well. It slowed those particles down, and they're not hitting the walls of that container as much anymore. They're not putting a force on that wall anymore. So you can see we still got a couple of stray gas molecules, but most of them have settled back down into sort of a liquid state at the bottom. So when I bring the temperature down, it brought the pressure down as well. So opposite question, what happens if I heat these particles back up? You can see as I'm adding heat, they start to get faster. I'm adding more energy, so they get faster. And the pressure, take a look at what that's doing and answer the question that's in your notebook. All right, last question. We're going to slow these particles down a little bit so we don't overheat our container. But now I'm looking for what happens to the pressure if I decrease the volume of this container. So I'm going to pull this lid down to make the volume smaller. Less room for those gas particles to move around in. And take a look at that pressure gauge as I'm pulling this down. Once I bring that down, that pressure goes up dramatically. And if I keep pushing on it and keep pushing on it, the pressure builds up so much that the entire thing explodes. So go ahead and answer those 4 questions in your notebook. Take a second, pause, write them down, and then we'll move on to our next thing. So 2 more vocab words that I want you to know, now that we've seen that simulation, are proportional and inversely proportional. So if something is proportional, or if 2 things are proportional, 2 variables, that means when one variable increases, the other is going to increase with it. if one variable is decreasing, the other is going to decrease with it. They increase or decrease together. The opposite of that is if something is inversely proportional. That means when one increases, the other will decrease, or if one decreases, the other increases. They're going to move in opposite directions. So proportional and inversely proportional are opposites. So the simulation we just watched and the questions that you just answered are the basis for what we call the gas laws. So gas laws tell us about the relationship between pressure, volume, and temperature of a gas. They don't always apply to liquids and solids, but for gases they're pretty consistent. They can also tell you what will happen if I change one of those three things, and there are formulas that go with them that tell me how much I'm going to change by. So our first gas law is Avogadro's law, and his law is that the amount of a gas that you have in a closed container and the pressure in that container are proportional. He also said the volume in that container is proportional. So if you're increasing the amount of particles in a container, then you're also increasing the pressure and volume in that container, provided that your temperature is staying constant. Our next law that we're going to look at is Gay-Lussac's law. So this law says that the pressure and temperature of a gas are proportional. So pressure and temperature are proportional, meaning if pressure increases, temperature also increases. If temperature increases, then pressure also increases. Same thing if they're decreasing, they go up or down together. And this law is assuming that you're not doing anything to change the volume. If you were changing the volume, that law might not hold true. The third gas law that we're going to talk about is Charles' law. This law says that volume and temperature are proportional. So if your temperature goes up, your volume goes up. If your temperature goes down, your volume also goes down. So if you had something like a balloon or the tire on a car and the temperature went down, it got cold, that volume is going to shrink. Same thing in reverse. If the temperature goes up, it's a very hot day, you take a balloon outside, you might notice that that balloon expands a little bit because the volume is increasing as the temperature is increasing. And this law, again, is assuming that you're not changing the pressure, you're only changing temperature and volume. The last gas law that we're going to talk about comes from our old friend Robert Boyle. Boyle's law says that volume and pressure are inversely proportional. So this is the only relationship we've talked about so far within inversely proportional variables. In this case, he says that volume and pressure are inversely proportional. So if your volume increases, your pressure decreases. You're giving more space to your gas, it's not being pressed as tightly. If your volume decreases, like we saw in the simulation, your pressure is also going to increase rather than decrease because they are inversely proportional. And again, Boyle's law assumes that you're not changing the temperature. So you might have noticed in our gas simulation that all three of these things actually change at the same time. It's more convenient for us to talk about them individually. So we talk about the relationships between volume and temperature. We talk about the relationships between volume and pressure. There is another gas law called the ideal gas law that combines all three of these, which we're not going to get into in this unit. But just know that with these four laws that we've talked about, so Avogadro's law, Gay-Lussac's law, Charles' law, Boyle's law, there's always changing two things and one thing staying the same. So you're changing volume and temperature, or you're changing temperature and pressure, but the third thing is always staying constant. One last thing before this video ends, you have homework assignments every day this week except for Wednesday when we're doing the virtual lab. I have set it up so that you must complete the assignments in order this week. You start with Monday. You do the notes. You can use your notes on the homework. You get 2 attempts. If you lose an attempt due to technical issues, that is too bad. You're down to 1 attempt. You must complete the homework before Schoology will allow you to work on any of the Tuesday work. And you have to complete all of Tuesday's assignments before it will let you complete Wednesday's. Good luck.